Hello everyone, welcome back to Basic Electrical and Electronics Engineering. Today we are going to discuss a new topic, that is transformer. What is meant by transformer and how it works? What is the working principle of transformer? So let's get started. The transformer is a static device which is used to transfer electrical energy from one circuit to the another circuit. It is a static device, that means it does not contain any moving parts. Okay, and which is used to transfer electrical energy from one circuit to the another circuit. What is the purpose? With increase or decrease in voltage and current, but without change in frequency. It is a static device which is used to transfer electrical energy from one circuit to another circuit with either increase or decrease in voltage or current, but without change in frequency. That means at the input we have electrical supply, at the output also we have electric energy we get. But what is the purpose of using transformer? To transfer electrical energy from one circuit to the another circuit with increase or decrease in voltage and current as per our requirement. But remember that without change in frequency. That means the frequency of input supply and frequency at the output both are same. Suppose we have 50 Hz at the input, then we will get 50 Hz at the output. Suppose we have here 100 volt, we will get here 10 volt, or we have here 100 and we are getting here 200 volt. Here this is about, suppose we have here 10 ampere and we are getting here 100 ampere, and suppose we are having here 5 ampere, then if we are getting here 2.5 ampere, that means what? We are either increasing or decreasing the voltage and current as per our requirement, but that did not change the frequency of input from input to the output. This is a real picture of a transformer which we use in regulator power supplies or you can say your mobile charger. You may have seen this mobile charger. We use this type of small size transformers to step down the supply, that means to decrease the voltage from 230 to required value, say 9 volt or 5 volt. Okay, this is a symbolically representation of a transformer where here one winding is there, here we have second winding, and this material is called as core, which is made up of either iron or steel, on which these two windings are wound. When the supply is connected to any one of the winding, that winding is called as primary winding, and when the load is connected to any one of the winding, that winding is called as secondary winding. That means the winding which is connected to supply, we call it as a primary winding. The winding to which load is connected is called as secondary winding. That means this is our primary winding and this is our secondary winding. Okay, and this is the symbol of transformer, where this represents the primary, this represents the secondary. Observe here, the primary is separate and secondary is separate. There is no electrical connection or electrical contact between primary and secondary. Okay, then how it works? These are the practical examples or practical pictures that we are using. This is a small size transformers which we use in electronic circuits. This one and this one are used as a distribution transformer, and this is a power transformer. Okay, which is used at substations. These two are used at distribution poles. These are distribution poles which are distributing power to various consumers. Okay, and this is the transformer. This is 3-phase transformer, this is also 3-phase transformer. These are also 3 single-phase transformers. This is for 1 phase, this is for 2nd phase, and this is for 3rd phase. And these are all single-phase transformers. Okay. Then, how this transformer actually works? Observe here. This is a AC power supply. That means this is our primary. This is primary winding, and as the load is bulb, so bulb is connected to this red winding, so this will be our secondary winding. And this is our core, magnetic core or core, which provides path for the flow of magnetic flux. Okay. Now, what happens when we switch on this AC power supply? The source gets connected to this winding, and current starts flowing through this winding. Okay, through all the turns and get back to this source only. So current is flowing in the primary winding, so this current will be primary current. Now we know that whenever a conductor carries current, flux is produced around that conductor. This is our conducting material or winding or coil, and it is carrying current, so it produces flux lines. These are the dotted lines are the magnetic flux phi, which is measured in Weber. So it produces a magnetic flux lines, and this core material having a low reluctance property. Low reluctance property. Reluctance means it is the property of material to oppose the flow of flux, and it is having low reluctance. That means it is allowing flux to pass through it. So all the flux lines are passing through this core material only. Now what happens when we connect the load to this winding, the secondary winding? Then these flux lines are linking with this winding. These flux lines are linking with this winding, and due to that an EMF gets induced in the secondary winding. Here we will get EMF because this AC power supply, we are providing AC power, so this current will be AC only, and when the AC current is supplied to the winding, the flux produced by the winding will be also alternating in nature. That means it is changing with respect to time. So this changing flux is linking with secondary winding. So what will happen? The EMF gets induced in the secondary winding according to the Faraday's law of electromagnetic induction. And when the EMF is induced in this winding and it is connected to the load, that means it becomes a closed circuit, then current starts flowing through this winding and this bulb will glow. Okay, this bulb will glow. As soon as when suppose we switch off this power supply, then what will happen? The current becomes 0. When this current becomes 0, flux becomes also 0, and when there is no flux, there will be no flux linking with this winding, so EMF automatically becomes 0. So when EMF is 0, this current will be 0 and the bulb does not glow. Okay. This is a working principle of transformer. When the AC source is connected to primary winding, current starts flowing through this primary winding, which produces flux which is alternating in nature. Alternating means whose value is changing with respect to time, and this alternating flux is linking with secondary winding as it is wound on the same core material. So when it links with the secondary winding, an EMF gets induced in the secondary winding according to Faraday's law of electromagnetic induction, and due to that this load which is used bulb here will glow. Okay, this is a simple working principle of transformer, any transformer. It may be distribution transformer, power transformer, single phase transformer or 3-phase transformer. Okay, it works the transformer works on the principle of mutual induction. Mutual induction. Because it observe here, the primary and secondary does not have any electrical connection between them. Okay, even though we are getting this supply or voltage in the secondary winding due to this mutually induction principle. Okay, so this is the working principle of a transformer. See here, the transformer is a constant power device. Transformer is a constant power device. That means P input is equal to P output. Input power is equal to output power if we neglect the losses in the transformer. So that means what? Suppose we want here voltage is more, we want less voltage, that is we want to decrease the voltage with the help of this transformer. Then what will happen? This is the voltage, we want less voltage here, so automatically this current will increase here because this power is constant. Transformer is a constant power device. That means when we decrease the voltage, the current will automatically rise at the secondary side, so that this voltage and current product will remain constant. So VIN into IIN equals to V out into I out. Okay, and when we want this increase in voltage, then current will be automatically reduced as compared to this primary winding. So remember that this transformer is a constant power device and constant frequency device. That means frequency also remains same from primary to secondary. Okay. Let's classify the transformer according to the number of phases, construction, voltage level and its applications. So now according to the number of phases, we have the single phase transformer and a 3-phase transformer. Okay. Then according to the construction, we have this core type and shell type transformers. According to the voltage level, either step up, step down and isolation. That means step up means increase in voltage, step down means decrease in voltage, isolation means only provides isolation from one circuit to the another circuit without increase or decrease in the voltage. And according to application where the transformer is, we are using the transformer, according to that we have power transformer, distribution transformer. For welding process we have welding transformer, then audio frequency, radio frequency transformers and pulse transformer. These are the various types of transformer we have. We are going to discuss this transformer in detail in the next session. Okay. So this is all about what is meant by transformer, how it works. In the next session, we will see the detailed construction of transformer. So till then, stay tuned and keep learning. Thank you.